See it again. So finding vertical asymptotes. So to find the vertical asymptotes, that's going to be where the denominator is equal to 0, because you're not allowed to have that x value. So, and that's also on the front page how we found the domain restrictions. So if this is our function, x minus 1 over x plus 3, what value for x would produce an undefined answer, would you say? So what value for x is not allowed? -3. So my vertical asymptote is x equals -3, because a vertical line is x equals. The way I would write my domain, x cannot equal -3. So the equation for an asymptote is an equation, and the way you write domain is what x cannot be equal to. So this should have an equal sign, and this should have a cannot equal sign. All right, so the second example, first, I would need to factor the denominator. So actually, the work that you're doing these next couple days is helping you practice your factoring skills, which you're going to use when you retake part of your test next week. So this would factor into what? X minus 1 times x minus 1. So I didn't get any new, solution, but I have one undefined value, and that's when x is positive 1. So x equals 1 is the equation of my vertical asymptote, and my domain would be written x cannot equal 1. So that's vertical asymptotes. So we're going to practice that many, many times. So that's the denominator. Remember, the numerator was how we actually found our x-intercept, right? If the numerator is equal to 0, that's an x-intercept. If the denominator is equal to 0, that's a vertical asymptote. So when you start putting kind of all this 4 skills together, y-intercept, x-intercept, vertical asymptote, horizontal asymptote, now you've got 4 things to remember. So that's why if you do it in the same order each time, it helps you kind of remember that process. Okay, so then you have to find, step 4 is going to be finding our horizontal or slant asymptotes. So to do this, you're going to compare the highest power of x in the numerator with the highest power of x in the denominator, basically the degree, right? We just spent time learning the degree of a polynomial. You're comparing the degree of the polynomial in the numerator with the degree of the polynomial in the denominator. So there's 3 different outcomes, right? So if the denominator wins, numerator over the denominator, so I'm making the denominator win, then the asymptote is always y equals 0. So in this case, the numerator was constant, the denominator had x to the first, so the denominator had a bigger value. When I plug in 1 million, like a really big number, see how you're going to get 1 over 1 million? So that's 0.000001. So that is approaching a y value of 0. So if the denominator is bigger, your asymptote is y equals 0, and it's horizontal line. If the powers are the same after they compete, so the numerator and the denominator are equal in powers, the rule is that you peel off the coefficients of the 2 terms. So in this case, the coefficients are 2 and 3. So y equals 2/3 is the equation of my asymptote. So up here, it was just y equals 0. The denominator is bigger. Here, if you plugged in 1 million, you would get 2,000,005, which is kind of insignificant, over 3 million less 2. So 2,999,998. So when you take 2 million and divide by 3 million, that approaches a number of 2/3. This little tiny +5 and this little tiny -2, that's what's keeping us away from the asymptote. So we're approaching the asymptote, but we don't quite get to 2/3. And if the larger power is in the numerator, so this time the numerator wins, it's going to have a slant asymptote. And you're going to have to actually divide the polynomials. So I don't know how you learned your strategies for dividing polynomials in Algebra 2, but some of you from other schools, you might have done long division. Some of you might have learned synthetic division. Some of you might have learned the box method for division. So we're going to have to practice our division skills to figure this out. So before I move on from this page, I just want to show you what the graphs of these 3 functions look like, just so you can start to understand what does a rational function look like? So 1 over x, right? So it had a y equals 0 asymptote. So here's y equals 0. See how the graph is hugging y equals 0? And it also has a vertical asymptote at 0, because that would make the denominator undefined. Here's my vertical asymptote at 0. If I try the second function, which was 2x plus 5 over 3x minus 2, what does that look like? So we said that it's approaching a value of 2/3. So when I go way out here onto this end, or way out here onto this end, it's approaching 2/3 as a y value. And let's see, where would the denominator be undefined? Positive 2/3. Here's my vertical asymptote at positive 2/3. And see how that's approaching 2/3 and that's approaching 2/3. So your asymptotes are framing out where the legs are going. And so what does the slant asymptote look like? So x squared plus 2x plus 7 over x minus 3. So a slant asymptote, whoops, it makes kind of one of the legs of your graph go as a slant. So this would have a vertical asymptote at 3. Here's my vertical asymptote at 3. And then this slant asymptote is going in this direction. If I make my y values go a little bit higher, you can probably see if I can see the other side of that slant asymptote. See how it's way up here? So it's hugging this slant asymptote. So we need to find out what the equation of that slant asymptote is. So we're going to use division. So I'm going to show you a couple different ways to do division. You just pick which way seems more familiar to you. Like, I'm not sure, people from other schools, maybe you did synthetic. People from last year, maybe you did synthetic. Other folks, maybe you did the box method. So I'm going to show you synthetic first, because that's the method that I would choose most of the time. So synthetic division, we want to take this numerator and divide by x plus 4. So when you do synthetic division, your first step is to set the divisor equal to 0 to solve for x. So -4 is what you plug in using synthetic division. Does this look familiar to any of you? And if it doesn't, you could use it or let it go. I'm going to show you 3 different methods for division. You just need to pick one that you're good at. So I'm going to put the coefficients of the dividend up here in the top row of this array of numbers. So 2 for the x squared, 3 for the x, -1 for the constant. It has to be in standard form. And if one of the terms was missing, like if I had 0x, I'd have to put a 0 there as a placeholder. Or if I had 0 as a constant and it just ended 2x squared plus 3x, I'd have to put 0 there as a placeholder. So you need all of your polynomial spaces accounted for. And the way you do synthetic division is you bring down the 2, or the first term, then you multiply -4 times 2 is -8. So -4 times 2 is -8. Then you add together these two terms. So this is multiply, and then this is add. So I add together 3 minus 8 is -5. So then I multiply again, -4 times -5, I get 20. And then I add together and get 19. So the division that I get a remainder of 19, remainder. I get this as my constant and this as my x term. So y equals 2x minus 5 is my asymptote. So I would dot in the line y equals 2x minus 5 if I was graphing this. Let me show you 2x squared. Oops. So 2x squared plus 3x minus 1 divided by x plus 4. And then I'm going to do a 2x minus 5 on the same graph. So the blue is going to be the rational function. And then I put the red line in just so you could see where the asymptote is. So see how the blue line is approaching the red line? That's what an asymptote is. So let me show you 2 different ways to do this division, and you pick which you're more comfortable with. So the next method that we at least learned at Kennett was something called the box method. And so for the box method, what you do is you put your divisor on the outside of the box. So, oops, sorry, you can't see that. All right, so there's my divisor on the outside of the box, right? We're trying to do the problem 2x squared plus 3x minus 1 divided by x plus 4. I'm looking for what would multiply to give me 2x squared plus 3x minus 1 inside the box. So my first term that I need to get is 2x squared because that's part of my dividend. So what would have to go on the outside of this box to give me 2x squared? Right, multiplication. X times what is 2x squared? 2x. Then I multiply to get this box. So 2x times 4 is 8x. How many x's do I actually want in my dividend? I only want 3 x's. I currently have 8 x's. How many x's have to go in this box so that my dividend adds together to give me just 3 x's? What would have to go here to equate for the 8x? Negative 5x. So negative 5x plus 8x would build the correct dividend of 3x. See how then negative 5 goes out here? X times negative 5 is negative 5x. 4 times negative 5 is negative 20. How do I get negative 1 as my final term? I would have a remainder of positive 19. So see how I do end up getting that same function, y equals 2x minus 5, as my, what am I getting? A quotient. All right, so that's called the box method. And then the other method that I always learned at my previous school, so those of you coming from another school, another algebra program, they might have taught you polynomial long division, which looks like this. So it looks like division when you divide numbers. So you ask yourself, x times what is 2x squared? 2x. And then you do 2x times 4 is 2x squared plus 8x. Put your bar and subtract both of those terms like you would when you're doing division. And then you have negative 5x minus 1 left. And then x times what will give you negative 5x? Negative 5. Take the negative 5, distribute negative 5x minus 20. Write your bar, change the signs. If you're subtracting them, you're really adding them now. Remainder of 19. So pick one of the methods to try. You know, stick with one method. The only time synthetic division doesn't work is when you've got a denominator that has like a bigger factor. So like x squared plus 2x plus 7. You can only use synthetic for linear divisors. I don't know. I probably will only give you linear divisors so that you could do synthetic division. Does one of those 3 ways seem familiar to any of you? Nat, which way did you learn? You learned synthetic. Brianna, Jack, none of them look super familiar. We might have skipped it your year of algebra 2. I don't know. Okay. Anything look familiar to you, Eve? Okay. Did you learn both? Okay, so you've got a method. Might not be familiar to you. It might have gotten cut off because of remote learning. So, okay, that's fine. So we're going to practice. I'm going to practice synthetic on H because see how I have a linear divisor? And I'm going to practice long division. Oh, no, I'm going to practice the box method, I think. Did you guys not learn the box method? So I don't know, box method or long division for this one. So if you were going to do synthetic division, you're trying to divide negative 2 into this array of numbers, but there's actually a term missing. See how x squared is missing? So your array is going to be 1 for x cubed, 0 for x squared, negative 2 for x, and positive 9 for your constant. So this is representing your dividend. This is representing your divisor. To me, it's memorizing though, and that's why synthetic, I think, kind of gets forgotten sometimes. Whereas long division, to me, that's something that you've been taught since elementary school, dividing numbers that way. So, I don't know, you pick. So bring down the 1. Negative 2 times 1 is negative 2. Add together what's in your array, so you get -2 coming down. -2 times -2 is +4. Add together the numbers in your array, and you'd have +2. And then -2 times 2 is -4. Add together, and you get 5. And then you build your function backwards. So this is your remainder, your constant, x squared. If you divide x cubed by x, it makes sense that your leading coefficient is going to be x squared. So you end up with a slant asymptote of x squared minus 2x plus 2. So that's what you get for division. You'll never have an asymptote that's a parabola, though, because asymptotes are only lines. So we would say, like, this doesn't have an asymptote, but we're just trying to practice our division skills right now. So it's not really asking you about the asymptote. All right, so the last one, why don't you try either doing it using long division, so x squared plus 2x plus 1 divided into x cubed minus 2x squared plus x minus 9. So either try it that way, see how far you can get, or try it this way. And actually, I think the box method might be easier setting up your divisor on this side of the box. And that way you can go as far as you need to go. So x squared, 2x, 1, x cubed goes up there as your first term. So why don't you just see how far you could go with the division and see where you get stuck? And then so if we're doing the box, I'd say that x has to go up here, so that x times x squared is x cubed. So then I follow it through and do any other box that I possibly can. So 2x squared, 1x. So then we're looking here so that my x squareds add up to a total of -2x squared. Oh, so Cole, I think I didn't tell you the right thing then. You put -2x squared here, didn't you? These two together have to add up to -2x squared. So this has to be -4x squared so that these two boxes together add to -2x squared, which is our dividend. We're producing the dividend inside our box by multiplying basically our divisor by our quotient gives us our dividend. So this would be -4, wouldn't it? Did anyone else get that? So if that's -4, this is really your slant asymptote, or right there, y equals x minus 4 would be your answer. Everything else that we get is going to be remainder. So let's see, like if you kept going, -4x squared, -4 times 2x is -8x, -4 times 1 is -4. All together, my x's have to add up to 1x. So what's this? This has to be 8x, right? So that 8x minus 8x plus 1x is x. And then to get -9, this would have to be -5, right? So my remainder is 8x minus 5. I can't put anything else up here, right? Because I can't multiply by x squared and get 8x, right? So all of this is your remainder. The only thing we care about with rational functions is the divisor. So if you were going to do this one with polynomial division, you put the x up here because x times x squared is x cubed. X times 2x is 2x squared. X times 1 is 1x. Then you subtract this row of numbers. Gone. There's your -4x squared. That's gone. Here's -9. So see how you get -4 as your next term up here? -4 times x squared is -4x squared. The rest is remainder. So all I care about is the function, right? Once you get down to a constant term, you can't go any further. The rest would be a remainder. So, and slant asymptotes are not like the focus of rational functions, but it's one skill that I always see students have like a deficit in that makes it problematic to find those slant asymptotes.